Hello, my name is Jacob. Welcome back to the Introduction to Saint video series. In this example, we will show you how fun and easy it is to run a power system production cost optimization in Saint. Let's open the same electric network from the intro video. The model we are using is freely available via the links in the video description. Remember, this network has lines and transformers laid out over New England, along with all the other properties needed for production cost optimization. Next, we'll open a production cost optimization scenario. We'll use the peak demand week scenario. This scenario has all the time series and operational inputs for production cost optimization, including electricity demand, reserve requirements, fuel prices, and more. We can learn more about this scenario in the scenario editor. For example, this is a mixed integer program that will be solved using Gurobi, and it will be 7 consecutive daily optimizations, each with a 1-day look ahead. Let's do a little cleanup so we can get a better view of our log window. We are ready to execute our scenario. While the scenario is running, the log window will keep us informed with what is happening during the execution. When the optimization is complete, this window will also show us a high-level summary of the generation mix, production costs, and runtime. Let's look at some more detailed results. This is a nodal model, so we will have time series LMPs for each node in the system. This plot shows us the generation dispatch separated by object types. There is some power from solar and wind, but most of the generation is coming from thermal resources. Using the Model Explorer, let's expand the Externals tab to see what objects we have in this system. We can see that there are 19 demands, 10 fuel generators, 3 wind generators, and 6 solar generators. These 2 shunt objects provide reactive power support in AC power flow scenarios. The Intro to AC Power Flow Simulation video shows how these objects operate using this exact network with this peak demand dispatch. Let's look in more detail at the fuel generators. These generators correspond to the thermal generation portion of the dispatch stack we saw before. The GenType property describes the technology for each fuel generator. There are 2 coal, 2 nuclear, and 6 combined cycle gas power plants in this network. Properties in blue can be edited by the user. Properties in green are model outputs, for example, the active power. I can also get that dispatch stack plot from before using the Model Explorer. Since we just solved this optimization, we are currently looking at the final time step. We can cycle backward through each time step, and we see a red bar in the chart which corresponds to the time step we are looking at on the table. We notice that we have a lot of generation from coal generators, while a couple of gas generators are not generating at all. Now, before we end this video, let's answer a question of interest. What would happen if we were to retire one of the coal power plants? We can answer this by adding an event to the scenario. Events in Saint describe the operational conditions, constraints, or controls for an object. We can add an event to turn the Bridgeport coal power plant off. We are going to turn off this generator in the middle of the week to better visualize the impacts of retirement. Now, let's resolve the scenario with the coal power plant retirement event. In the log window, we can see there are some differences in the results. Previously, the total production cost was slightly lower. This makes sense because we've turned off a generator that was cost-effective to operate. Let's use a script to create a custom dispatch plot that separates thermal generation by technology. In this plot, we can clearly see when the coal generator turns off in the middle of the week. The natural gas generators in the system turn on to make up for this difference in generation. I would encourage you to explore other model outputs including emissions, energy prices, and transmission line loading. In this video, we ran a production cost optimization for 1 week, analyzed generation dispatch, changed a generator's operating condition, and reran the model to analyze the impacts. Thank you for watching our video on production cost optimization. Hey there, just a reminder to check the video description for links to helpful resources like the model used in this video, other instructional videos, documentation, and our Saint user forum.